we were studying Newton's method, and in today's class we will take few examples of Newton's method. So this is the formula for Newton's iterations. Xn plus 1 equals to xn plus 1 denote next iteration. Next iteration is xn minus fxn upon f dash xn. Let us take one example. This example says that choice of initial guess is very important in Newton's method. So if you take wrong initial guess, you may not get answer. So question is that using Newton's method, to find a non-zero root of x equals to 2 sine x, correct to 3 decimals. So this is my fx, x minus 2 sine of x. You can write x minus 2 sine x, or you can write 2 sine x minus x. And you can check that x equal to 0 is a root, as x equal to 0, sine 0 is also 0, so 0 is a root. And if you draw both, so 2 sine x will be look like this, 2 sine of x. So this height is 2. सेम ही है जैसे sin x का ग्राफ है, just 2 times, twice of 2 sin x. And line y equal to x, so this is y equal to x, and this is one branch of 2 sin x. So x equal to 0 is a root, and this one is also a root. And in this problem, we need to find this root. Find a non-zero root of x equal to 2 sin x. Means at the point where x and 2 sin x, they are equal, so they intersect. Okay, so you need to locate this root, and this root lies between 0 to pi, and pi is 3.14, so it is before 3.14. And more precisely, you can check this function changes its sign in 1 to 2. 3 से पहले है, just 2 से भी पहले है. Answer is 1.89. You can check from sign change. Root lies between 1 and 2. So you can say that root lies in 1 to 2. So we can start with any point. So let us start with 1.1. Okay, so iterations are xn plus 1 equals to xn minus function xn minus 2 sine of xn, and derivative of this x minus 2x derivative, you can write here, derivative is 1 minus 2 cos x. So 1 minus 2 cos xn. You can simplify if you want by taking LCM. So after simplification, it is 2 sine xn minus xn cos xn, division 1 minus 2 cos xn, and n is a number 0, 1, 2, 3, etc. So you can start with any point. I am starting with 1.1. So next answer is, let us write next answer x1, which is 2 sine 1.1 minus 1.1 cos 1.1, then 1 minus 2 cos 1.1. So put your calculator in radian mode and then simplify. This answer is 8.453. Okay, so root lies between 1 and 2. And I'm starting with 1.1. So what is the answer? 8.4. So you are going very away. So it may happen in Newton's method like कि मान लो let us say कि 8.453, let us say this is the root, so I am starting from here. So here tangent will be parallel to x-axis, and in that case derivative would be 0, almost 0. And we will see, in fact, this is the case in this example. Okay, so let's write first few iteration, then we will see. So first answer is 8.453. Now fit 8.453 here, 8.453. Simplify it. Next answer is 5.256. And the next answer is 203. The next 4 is 118.019. And x5 is minus 87.471, etc. and so on. So you are getting zigzag answers. So 5, 203, 118, minus 87. If convergence occurs, then you will be near root, but you are going away. And next answer is minus 203 if you write x6. So this means you can say the iterations are not converging. क्यों नहीं कन्वर्ज कर रहा? क्योंकि रूट आपका 1 और 2 के बीच में है, तो आंसर लगभग उसी के पास आना चाहिए. अब प्रॉब्लम क्या है यहाँ पे? सो हियर आपका डेरिवेटिव देखिए, डेरिवेटिव क्या था? 1 माइनस 2 कॉस एक्स. इससे डिवाइड कर रहे हो, 1 माइनस 2 कॉस एक्स. दिस कैन बी 0. सो हियर 1 माइनस 2 कॉस एक्स, दिस कैन बी 0. अब 0 कब होगा? जब कॉस एक्स आपका क्या आ जाएगा? हाफ. और कॉस हाफ कब होता है? लगभग 60 डिग्री पाई बाई 3 पे. एंड पाई बाई 3 इज अप्रोक्सीमेटली 1.0472. सो डेरिवेटिव इज 0 एट 1 पॉइंट समथिंग. और हम शुरू किससे हमने किया है? 1.1 से. तो कहने का मीनिंग है इस पॉइंट के नियर डेरिवेटिव की वैल्यू जो आप डिवाइड कर रहे हो दैट इज ऑलमोस्ट 0. So your choice of initial guess is wrong. Okay, so uh, here near, so in this case near x0 derivative is almost 0. So we need to change the initial guess. अब देखो रूट तो है 1 और 2 में. So let us start with 1.5. Let us start with 1.1 पे प्रॉब्लम है, थोड़ा आप आगे चले जाओ. लेट अस स्टार्ट 1.5 टू कहीं से भी शुरू कर लो. सो इफ यू स्टार्ट विद 1.5, then next answer is 2 sin 1.5 minus 1.5 cos 1.5. फार्मूले में फिट कर दो इटरेशन में. सो आफ्टर फिटिंग 1.5 आंसर इज 2.076558. एंड देन यू फिट, अब ये फिट कर दो x की जगह 2.0 समथिंग. Next answer is 1.910507, and next answer is 1.895622, and x4 is 1.895494, and we need to write answer correct to three decimals, so you can stop here. 1.895, 1.895. And if you write next iteration, so that is x5, that is 8.95494. x4 and x5, they are equal. Okay. So you can say correct to three decimal is 1.895. Any doubt in this? Hmm?
सो इसमें हिट एंड ट्रायल करना पड़ेगा बार बार कि वो कौन से पे जा रही है.
आपने डेरिवेटिव जो जिससे डिवाइड करे ना उसको एक बार थोड़ा सा चेक कर लो इनिशियल गैस पे, वैल्यू निकाल लो उसका. अब यहाँ पे 1 - 2 cos x था, तो ये 0 हो सकता है ना. कब होगा? जब cos x हाफ हो. हाफ
Yes.
मतलब π/3, तो π/3 लगभग 1 पॉइंट समथिंग 1 ही है ये. तो 1 के नियर ना शुरू करो, थोड़ा आगे चले जाओ आप. ठीक है.
ओके सर.
तो पहले पहले ब्रैकेट कर लो. ब्रैकेट कैसे करना है कि बाइसेक्शन वाला, कि जिसमें साइन चेंज हो. साइन चेंज है तो रूट है. न्यूटन में एक प्रॉब्लम है, आपका डेरिवेटिव 0 नहीं होना चाहिए बस. ओके. Also we will study some cases later on that what will happen if derivative is 0. So that is a special case that we will study after that. So here you can stop. So now you can check your answer. Previously they were zigzag. Okay. And now 1 point, 2 point, 1 point, 1.8. So they are quite close to each other. So if convergence happens in 3-4 iterations, you will get an indication that you are getting correct answer. So let us take one more example. This is an application of Newton's method to find maxima or minima. So this says that find correct to 5 decimals the x coordinate of the point on curve y equals to log x, which is closest to origin, which is closest to the origin using Newton's method. So this problem says that you have a curve, any curve. So this is the origin 0 0. मान लो ये roughly graph है log x का. So find a point on the curve. So there are many points. You need to find a point which is closest to the origin. Okay, so let us write this is the distance of origin from any point xy on the curve, and then you find minimum of this distance using Newton's method. Okay, clear the problem? So for this we take any point on the curve and then we will find distance, and you know the distance formula. क्या होता है formula? x1 minus x2 square plus y1 minus y2 square and then square root. So if you have point x1 y1 and x2 y2, then this is the distance formula. So we will use this formula to write distance. So for this, firstly take a point xy, y will be log x. Let xy be any point on curve. On curve y equals to log of x. Then distance from the origin is, let us write distance with d. Distance क्या होगा? x minus 0 square, x coordinate का difference plus y coordinate का difference. And distance depend on x, so you can write dx. X square, y is log x, so this is log x square. अब अपने डिस्टेंस का क्या निकालना है? मैक्सिमा और मिनिमा. डिस्टेंस पॉजिटिव है. अब एक्सट्रीम वैल्यू निकालना है. एक्सट्रीम वैल्यू कहां पे मिलेगा? फॉर एक्सट्रीम वैल्यू डेरिवेटिव टेस्ट लगा दो. तो डेरिवेटिव ऑफ डी, जैसे आप कोई फंक्शन का मैक्सिमम मिनिमा कहां पे मिलता है? जहां पे डेरिवेटिव जीरो हो. तो यहाँ पे डी का मैक्सिमम मिनिमा कहां पे मिलेगा? जिसपे डेरिवेटिव जीरो हो. सो राइट डी बाई, to differentiate it, you can also scale on both sides. Okay, so if f is minimum, then so is f scale. Or you can differentiate it directly. अब differentiate कर दो. तो डेरिवेटिव क्या आएगा? 1/2 x square plus log x square. पावर सॉल्व होगा पहले, पावर में एक कम. फिर x square का डेरिवेटिव 2x, log x square का 2 log x, और log x का 1/x. अप्लाई चेन रूल. And you can leave this 2 and this division factor, take it in right hand side. You can also cancel 2. So this is x, 1/x log x equals to 0. Or you can multiply with x. So x square plus log x equals to 0. So in other words, the root of this equation will give extreme value, that will give minimum distance. Now you have a nonlinear equation and you don't know how to solve it directly. So we say this is fx and we will apply Newton's method on this f. Okay, so now apply Newton's on this. And you need to find point near origin. So you can start with any point near 0, or you can check point by changing its sign. So firstly write its derivative f dash x, which is 2x, and log x is 1/x. Then Newton iterations are so xn plus 1 equals to xn minus function, then divide by its derivative. So let us start with initial guess. You can start with 0.1, 0.2. So I am starting with 0.5. So let us start with 0.5. Then first answer is 0.5 minus 0.5 square log 0.5, 2 times 0.5 plus 1/0.5. So simplify, this answer is 0.647716. Now fit this answer. Okay, 0.64 here. Replace xn with this number. Next answer is 0.652917, and next answer is 0.652919. And we need to find x coordinate correct to 5 decimals. So you can check 5 decimal digits are same. 0.65291. So you can make a conclusion that root correct to 5 decimals is 0.65291. This one. Okay, so this is another stopping criteria in which you check the digit in two consecutive iterations. So first 5 matching, then you stop. And also you should take care of this important point that if you want to match 5 digit, then you need to take 6-7 digit minimum. ऐसा नहीं है कि आप सारे आंसर को 5 में लिखो. अगर 5 मैच करने हैं, write more than 5. So I am writing with 6. It's better you write with 7. अगर 5 मैच करने हैं तो 7 तक लिखो. If you want to match 3 digit, then write 5 digit. Okay, and also you should be clear about, you should learn use of calculator. Okay, you need to calculate these things repeatedly. So try to learn the use of scientific calculator. That will be helpful in the written exam. Okay, any doubt in this example? So this root, so this is the x coordinate of point. This is the x coordinate of point on curve log x, which is closest to the origin. Okay, so you can say, so root correct to 5 decimal is this, which is closest to the origin on curve y equals to log of x. So let us take one more example. This example is very important example. This example says that you can put a broad heading that what will happen if derivative is 0, if f dash x equals to 0 or not defined. Okay, so what will happen if derivative is 0? And I hope these are two different situations. 0 means, let us say you have sine x. When x equal to 0, this is 0. So, okay. And not defined means, let us say you have sine x by x. So this is 0 by 0 form. Although it is 1, but if you fit x equals to 0, this is not defined. Limiting case, it is 1. Okay, so it may happen that derivative is 0 or not defined. In that case, you can apply Newton's method, and this depends only on problem. In some problem you will get answer, in some problem you may not get answer. एक तो हमने कर लिया पहले, जैसे फर्स्ट था एग्जांपल, फर्स्ट में डेरिवेटिव 0 था, so you are not getting convergence. But here I am saying that derivative is 0 at root, or you can say what will happen if f dash x equal to 0 not defined. You can add at root x equals to r. In that problem, derivative was 0 for initial guess, but root is 1.89. Okay, but at 1.89 it is well defined. So what I am saying, so what will happen if derivative is 0 or not defined at root? So let us take this example. So I am solving two problems here. So one is, first problem is, let us say this is A. It says that use Newton's method to solve x 100 equals to 0 with initial guess zero point 0.1, and in part B same, use Newton's method to solve 3x 1 by 3 equals to 0 with initial guess same zero point 0.1. So you need to solve two problem, x 100 equals to 0, and you can see clearly x 100 equals to 0, रूट क्या है, x equal to 0, उसको फाइंड करना है हमने, x equal to 0. In second case, x power 1 by 3 equals to 0 means x equal to 0. So in both cases we have 0 root, and we are finding this root starting with 0.1. Okay, so let us solve part 1 first. We have fx equals to x power 100, then its derivative is 100 x power 99, and Newton iterations are xn plus 1 equals to xn minus fxn upon f dash xn. So this is xn, function is xn 100, derivative is not 100. So take LCM and simplify, it is 99 by 100. Okay, xn, or you can say 0.99 xn, and then is 0, 1, 2, 3, etc. So these are Newton's iterations. So you can see here, so you can start with 0.1, and xn plus 1 equals to 0.99 xn. So first answer will be 0.99 times 0.1. So this is 0.099. Now fit this answer, 0.99 times this number, then you got 0.09801. Then x3 is 0.09722099. x4 equals to 0.096059601. And let's write first 5 iteration. Okay, so these are first 5 iterations. And you can check, so slowly अब xn plus 1 क्या है, 0.99 xn है. So slowly you are getting an answer. But we have seen in previous examples, you are getting answer in just 3-4 iterations. And here you can see method is very slow, but still you are getting answer. So what is the problem in this case? You can check that. What is the derivative? This one, 100 x power 99. And 0 is a root, and derivative is 0 here. So यहाँ पे क्या है? Here f dash 0 equals to 0, and Newton's method is slow. Is slow. Also, you can write error. So what I write? So I have written xn plus 1 equals to 0.9 xn. Root is 0, so you can subtract 0 on both sides, so that does not make any difference. And if you put a modulus, you can put a modulus here, modulus on both sides. And left hand side is error at n plus 1 step equal to 0.99 error at previous step. Can you let me know what is the order of convergence here by definition? देखो एक बात क्लियर है, ऑर्डर ऑफ कन्वर्जेंस न्यूटन मेथड का मिनिमम 2 होता है. मिनिमम 2 कब होता है? व्हेन यू हैव f dash x नॉन जीरो. When derivative is non-zero near root or root, then you get minimum second order convergence. But this is the case of failure where derivative is zero at root, but still you are getting answer, and by definition convergence is linear. En plus 1 equal to 0.99 en power 1. So here in this case convergence is linear. So in other words, if derivative is zero, you are getting linear convergence, and which is usually less than normal convergence of Newton's method. और एक पॉइंट इंपॉर्टेंट है, सेकंड ऑर्डर मिनिमम कब देगा, जब डेरिवेटिव नॉन जीरो हो. अगर डेरिवेटिव जीरो, दिस इज एन एग्जांपल इन विच यू आर गेटिंग लीनियर कन्वर्जेंस. तो न्यूटन हमेशा क्वाड्रेटिक नहीं देता, इट कैन गिव लीनियर कन्वर्जेंस व्हेन डेरिवेटिव इज जीरो. Okay, so let's take second part. In second part, you have fx 3x 1 by 3 and derivative is f dash x. So, which is x power minus 2 by 3. And Newton iterations are xn plus 1 equals to xn minus fxn divided by derivative. So, this will be numerator. If you take in numerator, it will be x power 2 plus 2 by 3. So after simplification, this will be xn minus 3xn. So this is minus 2 of xn. Now start with 0.1. So first answer is minus 2 times 0.1. So first answer would be minus 0.2, 0.2. Then you fit minus 2 point minus 0.2 minus 2 times xn 0.4. Then x3 is minus 0.8, x4 is 1.6, etc. And in this case, root is 0, same, but answer are 0.1, 0.2, 0.4, 0.8, plus minus sign के साथ 0.8, minus 0.8, 1.6. So answer are increasing either on negative side or on positive side. So you have root here. कुछ आंसर पॉजिटिव साइड जा रहे हैं, कुछ नेगेटिव, सो यू आर गोइंग अवे. So what is the problem here? At x equal to 0, derivative is not defined. So this is 1 by x. So this is 1 by 0. So in this case, method is not converging. Not converging. And f dash 0 is not defined. So we have studied two cases here. First, derivative is 0, then method becomes slow. And second case, when derivative is not defined, and in this case method is not working. And please be remember that Newton's method gives second order convergence if derivative near root is non-zero. And if derivative is 0 or not defined, then it depends on problem. Either method works or method may fail. If method works, then convergence can be slow. So that's it in Newton's method. Now we move to, so until now we have studied bisection method that has linear convergence. Then we studied fixed point method that will give you first order convergence, second order depending on derivative. Then you have studied secant method, and then you studied Newton's method. And if derivative is non-zero, and this is the best method which give you second order convergence. So let us move to now last method of this section, that we apply Newton's method for multiple roots. So this is the best method. We have studied which has second order convergence, provided derivative is not problematic. So Newton's method for multiple roots. So I have given definition of multiple root in the beginning. So multiple means that repeated roots. For example, I have equation x minus 1 equals to 0, then x equal to 1. This is called simple root occurring one time. And let us say if I have equation x minus 1 square, then this will give you x equal to 1, 1, 2 times. So we say this is a multiple or double root. Okay, occurring 2 times minimum. अगर 3 होता तो यहाँ पे 3 आ जाता, तो उसको ट्रिपल बोलते हैं ना. So this occurring is non multiplicity. कितने बार आ रहा है? So it occurring 2 times. So we say this is a multiple root with multiplicity 2. And more broad definition of multiple root is this that I am going to write here. So this is the definition of multiple root, you can say. So let R be a multiple root of fx equals 0 with occurring, or you can say with multiplicity m. So in this case we can write fx equals to x minus r power m multiplied by phi of x with phi of r equals to 0. अब इसका मीनिंग क्या है? जैसे ये इक्वेशन था x minus 1 square sin x, let us say x minus 1 cube sin x. तो यहां से आपको दिख रहा है क्लियरली x इक्वल टू 1 1 1 3 टाइम्स, एंड sin 1 इज सॉरी विद phi आर नॉट इक्वल्स टू 0, विद sin 1 नॉन जीरो. तो अगर sin 1 या ये भी जीरो बनेगा तो मल्टीप्लिसिटी क्या होगी? बढ़ जाएगी ना उससे. अगर sin 1 भी जीरो होता तो मल्टीप्लिसिटी कितनी आ जाती? 4 आ जाती है ना. 3 यहां से, एक यहां से रूट मिल रहा है. तो जब भी आपका रूट होगा, whenever you have a multiple root, you can always write it x minus r power m. It depend on you. Sometime you write it clearly, but sometime we don't know how to write it. For example, let us say okay, so also you can check here. Also in this case clearly you can say that fr equals to 0 root है, fr f dash r f double dash r, all derivative will vanish, and mth derivative at root will be non-zero. ये भी एक डेफिनेशन है मल्टीपल रूट की कि फंक्शन जीरो हो, फर्स्ट डेरिवेटिव सेकंड सारे डेरिवेटिव जीरो हो. अगर मल्टीप्लिसिटी 3 है तो थर्ड डेरिवेटिव नॉन जीरो होगा, फर्स्ट और सेकंड जीरो होंगे. वो कैसे होगा कि लेट अस से यू कैन टेक एन एग्जांपल. लेट अस टेक let us take fx equals to x minus 1 square x plus 2. So you can check here x equal to 1 is a multiple root with multiplicity m2. So in this case you can check f1 is 0. Now differentiate it f dash x. So 2x minus 1 x plus 2 product rule of x minus 1 square x plus 2 equals to 0. So you can check f dash 1 that is also 0, fit x equal to 1. दिख रहा ना? अब डबल रूट है तो सेकंड डेरिवेटिव कंप्यूट करो. राइट एफ डबल डैश एक्स दैट विल बी 2 टाइम्स x plus 2 plus 2 times x minus 1 x plus 2 का डेरिवेटिव 1 then 2 times x minus 1 2 times x minus 1 x plus 2 plus x minus 1 square, then derivative of x plus 2 is 1. So if you fit 1 in second derivative, so that is now 6. This term x equal to 1 and all term will vanish. So in that case you can see x minus 1 square, 1 is a double root, so first derivative is 0 and second derivative is non-zero, then multiplicity is of the root is 2. Okay, or let us take next example. Let us say you have fx equals to this x cube minus 3x square plus 3x minus 1 and root is r equals to 1. You can check one satisfies this equation 1, and in this case you can check f1 is 0, 1 minus 3 plus 3. Then write f dash x, that is 3x square minus 6x plus 3. And you can write f dash 1, that is also 0, 3 minus 6 plus 3. Then write f double dash, that is 6x minus 6. And you can check second derivative is also 0. So write third derivative, which is 6. So third derivative at 1 will be 6, that is non-zero. So you can check in this example, first derivative is 0 at root, second derivative is 0 at root, third derivative is non-zero. So multiplicity is 3. Okay. So multiplicity is 3. And if you would see more closely, so fx is in fact is this x minus 1 cube. उसका expansion करके लिखा हुआ है मैंने. If you expand x minus 1 cube, you will get this one. तो अगर आप ये फॉर्म लिखते हो तो क्लियरली दिख रहा है 1 multiple root of 3 टाइम, बट यहाँ से नहीं दिख रहा क्लियरली. Okay, so if you know the root, fit compute its derivative and start fitting root. First derivative 0, then compute second, second 0, compute third. अगर third भी 0 आता, fourth निकालो. अगर fourth derivative non-zero है, then multiplicity of root is 4. Okay, ये तो था कि कुछ direct problem है. तो let us take one more example, that is fx equal to 1 minus cos x and root is 0. You can check f0, 1 minus 1, 0. Now write f dash x, which is sin x, and f dash 0, that is also 0. Write second derivative, that is cos x, and second derivative, if you fit 0, then this is 1, that is non-zero. So first derivative is 0, second derivative is non-zero. So this implies multiplicity is 2. बट यहाँ पे तो दिख नहीं रहा क्लियरली आपको कि अब मल्टीप्लिसिटी 2 है तो इसका मीनिंग क्या है? रूट 0 है. सो व्हाट यू कैन राइट? सो वी कैन राइट fx, क्या लिख सकते हो उसको? रूट 0 है, ये लिख सकते हो आप इसको. अब कैसे लिखेंगे? फंक्शन तो हमारा ये था 1 माइनस कॉस एक्स. तो क्या आप इसको इस फॉर्म में लिख सकते हो? x के समथिंग. कैन यू राइट इट? लिख सकते हैं आप इसको. 1 माइनस 2 कॉस एक्स क्या बनेगा? 2 साइन स्क्वायर x by 2. सो राइट इट साइन, यानी कि साइन एक्स बाई टू इसका स्केयर है, एक्स बाई टू से मल्टीप्लाई, ये स्केयर बन गया, एक्स बाई टू से आपने मल्टीप्लाई किया है, डिवाइड भी कर दो ये, तो ये टू टू कैंसिल हो जाएगा एक, सो बचेगा क्या, एक्स स्केयर बाई, so this is x square, this is phi of x, so what is phi x, this one, 1 by 2 sin x by 2, and clearly you can check here phi 0 is half, क्योंकि साइन 0 बाई 0 तो 1 होता है ऑलमोस्ट, सो दिस इज हाफ, तो वो डेफिनेशन बन गई ना कि इस फॉर्म में लिख सकते हो वेयर फाई एट रूट इज नॉन जीरो, सो फाई 0 इज नॉन जीरो. So if you have a multiple root, you can always write function in this form, x minus root, जो multiplicity है, साथ में कोई function और है. Okay? And if you fit this, so this will give you, you fit, this is equals to 0, so that will give you x equal to 0, 0 two times. But you can see from examples, it is not always possible or always easy to write in this form. So nextly we will study Newton's method to find multiple roots in next class. Any doubt?
सर लास्ट टू लास्ट एग्जांपल बता दोगे एक बार?
इसमें हमने कि अगर आपके पास रूट है तो आप इस फॉर्म ये लिख सकते हैं ना, मैंने लिखा बताया था x minus r power square. So I have written one, I had function 1 minus cos x. So what I require इस पहले ये लिख दिया 1 minus cos को, 2 sin square x by 2 होता है फार्मूला ये cos x का, 1 minus cos x का. अब मैंने x स्क्वायर मेरे को ये चाहिए यहाँ पे ना, अच्छा मैंने, तो यहाँ पे ये करो कि इस ये 2 sin square x स्क्वायर था, 2 तो है, सो आई नीड x स्क्वायर ही है, ये चीज थी, तो x स्क्वायर से मल्टीप्लाई डिवाइड कर दो, अब इनको एडजस्ट कर दो आगे फिर. मैंने क्या लिखा है इस फंक्शन को, x के टाइम्स समथिंग लिखा है, x के से मल्टीप्लाई डिवाइड कर दो, फिर इनको एडजस्ट कर दो. आई थिंक ये थोड़ा गड़बड़ लग रहा है इसमें, सब ये x से मल्टीप्लाई किया तो ठीक है, तो इस फॉर्म में लिख सकते हैं इसको, या आप ये कह दो, अब ये साइन x बाई टू था, तो यहाँ पे x बाई टू चाहिए, तो 2 से ये 2 एक्स्ट्रा है, तो 1 बाई 4 से आप डिवाइड करोगे इसको, तो ये 1 बाई 2 बच गया ये साथ में. यानी कि आपने क्या करना है इस फंक्शन को, क्योंकि x स्क्वायर इक्वल्स टू 0 बनाना है आपने, सो ट्राई टू राइट दिस फंक्शन x स्क्वायर टाइम्स समथिंग, जो बचे दैट फंक्शन इज नॉन जीरो एट x इक्वल्स टू 0. क्लियर है नहीं?
यस सर.
Try to write in that way, x square times something. So you don't have x square here, so multiply x square and divide, then simplify it. So try to write x square multiply by something, and that something must be non-zero at root, and you can check that sine 0 by 0, that is 1, so answer is half. Okay, so I'll stop now.